Hi, welcome to the last video of Chapter 8, Video 8.8b, Part 2, More Improper Integrals. This time the integrand is undefined between the limits of integration. Into two integrals, from one of them from 1 to 2 and the other one from 2 to 3. So, because the 2 doesn't exist there, we're going to have the limit is a approaches 2 from the left. Because we're now between 1 and 2, so we're on the left side of 2, and we replace that 2 up there by a, plus the limit as b, and you do have to use a different variable because they're approaching different quantities. So we replace the 2, which was here, we replace it by b, and now we're between 2 and 3, so we're on the right side of 2. Now one of the nice things about this is that it's the same integrand, so you just need to integrate it once. So if we integrate it, of course, we pull out the 2, and we're going to have x minus 2, the negative 5/3 over negative 5/3, which is negative 3/5. So we'll get the same thing over here. This one is evaluated from 1 to a, the other one's evaluated from b to 3. So remember, we always plug in the top one first. Remember, the limit's the last thing we do. So I just kind of simplified that a little bit. And now we're going to plug in the a, and then we're going to plug in the 1. Now when I plug in 1, I get negative 1 to the 5/3. Cubed root of negative 1 is negative 1. Negative 1 to the 5th is negative 1. And actually, there's a mistake here. Am I crazy? No. All right, this should be a plus. Ooh, I don't know how to go back. Okay. This should be a plus. Let me fix that right now. Right? Because if I plug in 1, that'll be negative 6/5, and I'm subtracting negative 6/5, so that'll be plus. And same thing over here. No, here though, when I plug in the 3, I will get positive 1. Okay. Sorry about that. At any rate, right away when we go to evaluate this limit, if we plug in 2, whoa, let me get rid of that. Okay, so do this. If we plug in 2, we get negative 6 over 5 times 0 to the 5/3, which is a non-zero over 0. Numerator is negative. Denominator is approaching 0 through negatives, because if I approach 2 from the left, I'm thinking 1.9 minus 2, that'll be a negative. Cubed root of a negative is a negative to the odd power is a negative. So it'll approach 0 through negatives, which means it's infinity, and then the rest of who really cares, although that is a plus again. Okay. So it turns out that this particular improper integral diverges. This is like number 20. The integral from 1 to infinity of 5 over x cubed dx. Again, you're going to have to notice it doesn't exist at 0, although that doesn't really matter here because we're going from 1 to infinity. But the infinity, of course, makes it an improper integral. So we replace the infinity by a, we write the limit as a approaches infinity. If you do not change it to a limit, you lose a lot of points because you're not doing the correct process at all. So then I'm rewriting 5 over x cubed is 5x to the negative 3. Integrated, plug in the a, plug in the 1. I simplified it a little bit. And then you end up with this expression right here. So that's just a constant. That's positive 5/2. And now we're going to let the a go to infinity. So what's going to happen is the denominator will be infinity. You'll have negative 5 over infinity, which is 0. And 0 plus 5/5 will be 5/5. So it converges to 5/5.